Good afternoon everyone, welcome to the channel. Today I am to talk about UMAP, the full form of which stands like Uniform Manifold Approximation and Projection, and this is a nonlinear dimensionality reduction tool which can be used for visualizing high dimensional data into either 2D or 3D space. So let's get started. At first let's give a header. Sorry, I have to align it. Okay, at first I want to import the required libraries. Let's import pandas, numpy, matplotlib. Okay, so these are our required libraries. Now let's load digits dataset from sklearn. Datasets dot load digits data digits dot data and labels digits dot target. Let's create a data frame. pd dot data frame data. Also I want to add the labels. On labels, let's see first few samples. Okay, so this is how this dataset looks like. 0 to 63 are the features and this is the class. Let's check the shape. So there are 1797 samples and 64 features, and last one is the class. Let's separate features. And labels. Okay, for getting the features you have to drop the last column from the data frame. So df.ilog, let's ignore the last column. Classes df.log. name of the column. Let's check the features dot shape. So you can see we have dropped the labels from the features. Okay, now let's perform pre-processing. Create an instance. Scaled features. Scalar. Fit transform features. Okay, now let's first visualize these features in 2D UMAP. So let's create an UMAP instance. Let's name it UMAP 2D. So UMAP. And neighbors, let's say 5. Min is 0.35. In components. In components 2 for 2D. Let's mention the random state 0. So reduced 2D. UMAP 2D. Fit transform. Pass in the scaled features. Okay, we have reduced from 64 into 2. And let's check the shape. So you can see we have 64 features. After performing nonlinear dimensionality reduction, we have reduced them from 64 to 2. You can also see how they look. Sorry, reduce 2D. So you can see two components. Okay, we can also check the unique labels in our dataset. So np.unique classes. So there are 10 types of digits starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's separate the two components for visualization. So reduced 2D. All rows, first column, this will be 2, this will be 1. Okay, let's make color dict. Red, yellow, five and 6. This is black. 7, coral. 8, gray. And finally digit 9, Peru. Let's copy. So we have a color dict. Now we want to prepare a label dict. So this will be 0, 1, from 0 to 9. 3, 4, 5, 6, 7, 8, 9. Okay, let's copy. We also have to prepare a marker tick. We will use different markers for different digits. Let's use O, P, star, plus multiplication D, S, P, less than, greater than. Finally, we have to use this will determine the size of the markers. Okay, now see the visualization after performing dimensionality reduction. Light gray for I in np.unique classes. Putting this line in a loop. np.where classes equal I. Perform a scatter plot. So comp 2d1, comp 2d2. Oh, sorry, I have to mention the J here as well. Color ticked I. Label ticked I. Marker ticked I. Alpha ticked I. Okay. Set X level UMAP 1. Font size. Let's say 15. Do the same for Y level as well. Set Y level. This will be second component. Set title. So we are doing the 2D UMAP visualization, 2D visualization using UMAP. Let's make it slightly bigger. Also, we want to add a legend. Title will be digits. Box to anchor. marker scale for making the marker size bigger. Font size will be 20. Title font size will also be. So this is underscore. I hope everything is okay. Yes, it is okay. So these are showing different digits. So 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. This is we plotted this after reducing 64 features into 2. So this is our 2D UMAP plot after performing dimensionality reduction. We can do this for 3D as well. Okay, so 3D UMAP. Let's copy few lines to save time. Okay, so this is 3D now. 3D, and instead of 2 components, we'll use 3 components for 3D UMAP. Okay, let's check the shape as well. Reduce 3D dot shape. So previously we had 1797 2. Now we have 3 components for 3D visualization. Let's check how they look as well. So you can see 3 components. Let's copy this line as well. So instead of 2, we have to mention 3. This will be 3, 3. We have to mention another one. So this will be 3. This will be 2. We can also copy this block of code as well. To change a few things, let's change figure size, and instead of 2D we have to plot 3D, so mention projection 3D. I want to change this as well, white. Okay, so this will be comp 3D 3J. Okay, so this will be 3D 3D. We have to mention another line, Control C, Control V. This will be my third component. This will be Z level. This will be 3D visualization using UMAP. We have to change these as well. I hope everything is okay. Yes. Okay, so in this case we saw 2D plot, and now we can see 3D plot. Okay, so this is component 1, component 2, component 3. These are showing, but 3D is little bit difficult to understand compared to 2D. 2D is better, I will say, for interpretation. This is kind of difficult to understand, but we can see all the 10 digits here as well. 1 2 3 4 5 6 7 8 9 10. Okay, so this is how we can perform dimensionality reduction using UMAP, which stands for Uniform Manifold Approximation and Projection. Okay, we perform this using the digits dataset from sklearn, where we have 10 types of digits that are represented by 64 features. We reduce them to 2 components for 2D visualization and 3 components for 3D visualization. Okay, so in the next video I will show another example using a different dataset, and that will also be dimensionality reduction, but we'll use TSNE, which is another technique for dimensionality reduction. Okay, that's the end of this video. Thanks for watching.